Relations and functions. A relation is a set of pair of input and output values. You can represent a relation in 4 different ways. The first being ordered pairs, or in a mapping diagram, table of values, or on a graph. Notice how it's the same information displayed in 4 different ways. We're going to create a mapping diagram for the following relation. 2, -3, 2, 3, 3, -1, 4, 3, and 6, 6. So the procedure for creating a mapping diagram, you're going to arrange the numbers in descending order. Don't repeat any numbers that show up more than once, and then you're going to use arrows to match input and output values. So for our inputs, those are all of the x values. So that's 2, 3, 4, and 6. So even though we have 2 twice, you don't need to repeat it. Same thing with the output values, -3, -1, 3, and 6. So now we're going to match up each input value with its output value. So the 2 is in a coordinate point with the -3, and it's also in a coordinate point with the +3. So you're drawing one arrow from 2 to -3 and another arrow from 2 to +3. 3 to -1, 4 to 3, and 6 to 6. A function is a very specific type of relationship. And in order for a relation to be a function, the elements of the domain, so those are the input values, correspond with exactly one element of the range. So those are output values. So what that means is a function cannot have any repeat x values. So if we take a look at these two relations, relation A and relation B, we're trying to determine which one is not a function. So when you look at relation A, the x value of 4 repeats itself. And if you look at relation B, we have -1, +1, -3, and +4. None of those values repeat. So relation A is not a function because the x value of 4 repeats itself. Now we're going to take a look at 2 mapping diagrams. We're going to try to figure out which one is not the function. So we're going to take a look at 2 different pieces. So relation E, the 2 is pointing to 2 different values. In relation F, 4 and 5 are both pointing to 6. So what that means is one coordinate point is 2, -3, and 2, -1. And in relation F, we have 4, 6, and 5, 6. Relationship E is the one that's not a function because 2 arrows extend from the input value of 2. So that means 2 is the value that's repeating itself. It's okay that in relationship F, the 6 repeats itself because those are y values. And it's the x values that matter. Here we have 2 graphs. We have relation C and relation D. To get a better idea of what's happening here, we're going to plot some points on both graphs. So here's some points on relation C. Here's some points on relation D. And in this case, relation D is the one that's probably not the function because the values 4 repeat itself, value 6 repeats itself, and the value 8 repeats itself for all of the input values. So whenever you're given a graph, you can use something called the vertical line test. So if you draw a vertical line anywhere on a graph so that it hits the graph in more than one spot, the graph is not a function. So here are the 2 graphs we were looking at before, and I drew a whole bunch of lines on both of them. The function on the left, the red function, each line only crosses my graph once, but the function on the right, the blue one, each vertical line crosses the graph twice. So that means relationship D is not a function because it fails the vertical line test. Domain and ranges. So domain, those are the input values. Those are the x values. The range is the output y values. So we have this function g of x, and I want to try to explain what the domain and the range is for both functions. So I need to figure out what the possible x values are. The easiest way to get this done is to draw some vertical lines on the left point and the right point. So what this helps me visualize is the possible values for x. And I can see that all my x values are going to be between -2 and +4. The way we write this in mathematical notation is like this. D colon bracket x colon -2 is less than or equal to x, which is less than or equal to 4. So that's basically just fancy mathematical notation that's saying x is between -2 and +4. We're going to do the same thing for the y values. Draw two lines, my highest point and my lowest point. And this helps me see that the y values are in between -1 and +3. The way we write this one is the range is in between -1 and +3. So range matches with the y's and domain matches with the x values. We're going to take a look at these two graphs. I'm going to do the same thing as I did before. I'm going to draw some lines on my graph to help me figure out what's happening with the x values and the y values. So first thing I'm going to do is I'm going to draw a vertical line, the farthest point to the left. I don't need another vertical line because my graph doesn't end. See that arrow on the end of the purple line? It doesn't stop, so I don't need an endpoint. What this tells me is all the x values are greater than -3. So then this is how we write it in the notation. I'm going to do the same thing for the range. I see that my highest point is +5, and then it keeps going down forever and it never stops. So all of my values are going to be less than +5. So then here's the range, y is less than or equal to 5. The other graph, I'm going to draw a vertical line. This time it's the farthest right it can go, which means x values are going to be less than 2. And my y values don't ever stop. They don't turn around. There's no high point. There's no low point, which means that y can be any real number. So the way we write this is r semicolon y semicolon y. This fancy little e, that represents the element, and this crazy looking r represents all real numbers. So whenever you have no limitation on your x or your y values, you use the element of all real numbers symbols. A function is given a name that can be a letter such as f or g. So function notation, which reads f of x, represents the outputs when the input value is plugged into an expression. So basically, f of x is pretty much the same thing as y. So we have this function here, f of x equals 2x squared minus 3. And let's say I wanted to evaluate this function for a specific number. So we have here f of 3. And what that means is it means to plug the 3 into the equation wherever you see an x. So f of 3, plug in the 3. Be careful when you calculate your numbers. Remember to use PEMDAS, exponents first. F of 3 is equal to 15. If g of x is equal to 2 over x minus 1, we're going to find g of negative 5, and then we're going to find g of 0. So again, whenever you see those numbers in a bracket, in a parentheses, you're just going to plug it in for x. So g of negative 5 should be 2 over negative 5 minus 1 equals negative 7 over 5. And then if we want to find g of 0, we have 2 divided by 0 minus 1. We run into a problem here because we are not allowed to divide by 0. Whenever you divide by 0, your function is undefined.